and that was Jimi Hendrix, and I was not keeping track of, that was Purple Haze still going on there at the end. Something to keep awake on, I think it's a Tuesday. So this is really our first full week without having either the start of school or a holiday. So we grind out 4 full days, and yesterday was spent on question and answers. And my hope was to get that homework back to you. That didn't work out last night, so perhaps tomorrow. The lab for this week is the lab on histograms. And it is a lab that, as I explained to you yesterday, is based on seeing what happens if you have not enough intervals and you have too many intervals. And of course, it's really nice to be able to tweak that with stat graphics and do it on the fly, compared to the length of time it takes to do one of these longhand and make adjustments. One of the things you're going to find, however, is that with a histogram, you can manipulate things in ways that are not to your best interest. So for example, if you have too many intervals, you can eliminate the appearance of a bell-shaped curve and replace it by something that may even look bimodal. In the same way, if you don't have enough intervals, you can lose the whole sense of bimodality. Remember, that's 2 separate bell-shaped curves within the same distribution. And you can eliminate that and just see skewing. So there is a kind of misrepresentation at your fingertips. Now, it also is sensitive to where you start your intervals and where you end them. And so we're going to follow that rule of thumb that you are going to take your lowest data value, drop the last digit by 1, and put a 5 after it. That's the way we're going to play the game. But when we see the defaults done by stat graphics, you're going to find that once you change the interval, it will change the appearance of the graph. Now, the intervals are basically done to the nearest 10. So if we had a value, as we do, for the birth rate down in the 7 range, stat graphics will just default to a 0. And if you go up to the 50 range, then it'll default on the other side at 60. And so it does change the appearance. That's one of the frustrations of histograms, that you can manipulate them. Stem plots are a little less inclined toward that, but you did find that if we split the stems, you can again introduce too much information. Now, stat graphics does not provide you the opportunity to do a split stem or not a split stem. Otherwise, it just defaults to a particular choice, and you cannot tweak it. So we are going to go ahead and look at the World Factbook 2008. That's where we'll start this morning. And when you do this in the lab, you're going to need some scratch paper to determine where your upper boundary is going to be. So let me at least go through that concept on the board before we start. If I give you a lower boundary, and I give you that I want 8 intervals, how would I be able to determine in one operation the upper boundary? So that I'll ask as a rhetorical question for the moment. So I start with the lower boundary. I want to know what the highest boundary, otherwise that last interval you have. What is the upper boundary of that? Just with one calculation giving you that answer. So that's the question. So we are using powers of 2 to determine that we want 8 intervals. Okay, 2 to the 7th is 128. 2 to the 8th is 256. We have 220 plus different pieces of data. So we'll want 8 intervals. My lowest data value, I believe, is 7 something. Do you have the database out where you can take that value? I believe it. 7, is that Hong Kong? Check the database. Let's see if I have that here where I can look it up real quick. Yes, I have that here. Let's see. This is for 2008, and I'm going to go to Was thinking Hong Kong may be the low one, but let me double check here. So I'm coming across for Hong Kong, and I'm seeing a 737, yes. So my lowest data value from 2008, and it's going to be to your advantage to, at this point during the semester, keep that in front of you. Otherwise, keep the 2008 database as part of what you bring to class. So our lowest value is 737. So what are we going to do to get our lowest boundary? Drop this last digit by 1, and then we are going to put a 5 after it. That's a consistent behavior. Now I want 8 intervals. I first have to find the width using the 8 intervals, and I need the range to do that. So this was my low value, and I believe Niger is my high value. Okay, now I'm going to have to turn a page here for my reference, and you can help me out to see if you concur with the value. But I'm seeing for Niger a 4962. Is that an agreement? Now I do not, and I want to emphasize this, I do not just add a 5 at the end of that to get my upper boundary. Now the difficulty in this is I have to scale this histogram on the horizontal axis. To do that I need a width that is not a repeating decimal and is not 15 digits long after the decimal point. So I'm going to, in a way, contrive a very acceptable value for the width that will generate then an upper value that is to my advantage. The range is simply the difference of these two. Now we're going to have to do that from the standpoint of a physical calculation when we work with stat graphics. And so it's going to be a 42, and it's going to be a 25, correct? Do you concur in the subtraction? I have 3 nods, 4 nods, 5 nods, okay? To get the width, I'm going to take this value and I'm going to divide it by the number of intervals, which is 8, which we defended. Now, what do we get from that on your calculator? And you need to have your calculator out pretty much on a daily basis at this point. So a couple things I want out as we go along, just so you don't have to be dragging things out in the middle of the lecture, is to go ahead and have your calculator, the database out, minimally your book out so you can reference that when we need to, and when we're doing labs, the lab manual. That's called basically being prepared. So what do you get when you divide? You get a 5 point what? 528? Now that is not a value I want. Rule of thumb, round this up to the nearest tenth. I didn't say round off. I said round up. So even if this was a 5.23, I'm still going to go up to 5.3. So this 8 is of no consequence to me. It could be any digit whatsoever. I'm going to round up to 5.3. Now the point is, if I take this 5.3 and multiply it by 8, and if I'm blocking in any way, just look at a monitor. Okay, if I take that 5.3 and multiply it by 8, add that to that 7365, I got my upper boundary. So this is the one operation involved. So you're going to take the 7.365 and add to that 8 times 5.3. Now by doing that, I'm going to have an upper boundary that is higher than my highest data value. Let me say that one more time. The intent here, and there are occasions with some data that I may not quite achieve what I want, but my goal is that this upper boundary is higher than the highest data value. Hence, all my data is in 8 intervals. Now, if it turns out that this value is not higher than the highest data point, then I will increase from 5.3 to 5.4. On rare occasions, that happens with data. So the goal here, one last time, and you're going to have to explain this in the lab, in the discussion questions, and you may well have to explain it on the first question, or first part of the exam, on part 1, exam 1, where I ask short answer questions, and I expect you to be able to defend your answer. Okay, so this is going to be 42.4, correct? When I multiply? So notice, by doing this, as I add that to here, I have not done anything to influence the hundredths or thousandths position. So I'm simply going to add these together, and I'm going to have a 49.765. The question, if I did my arithmetic correctly, the question, does it contain my highest data point? That is, that upper boundary. Yes, it does, and that was the intent. Now, you must do precisely the same calculations to create the horizontal axis values that you use to create the histogram. They must be totally consistent in stat graphics. You can't sit there and start trying to tweak the values in the horizontal axis. So what I'm going to tell stat graphics to do is to create a histogram going from 7365 to 49765 with 8 intervals with a width of 5.3. When I do that, I'll get what I want, and things will match up. Now, the question, where do you get help when this doesn't work like you thought? And as much as I try to be very precise in what you need to do, I do know that once you get into the lab, screwy things start happening, and nothing seems to work, and you get frustrated. And so where do you go to do this to get help? And this is one lab that you will benefit from that. What is the answer? Sierra Hall, 221, Clorinda. She's the person who can help, can straighten this out for you, and save you enormous amounts of time. If you have not yet gone out there, you are missing probably the most important resource of the class. Now, we just had a discussion briefly in here about what you can do getting into study groups and what you can do to help each other. And here you have an opportunity in one room on the West Campus with one of the nicest looking computer labs in the entire college setup of 20,000 people. You've got a resource out there that some of you haven't even gone to visit. That is insanity. You've got help, reach out. If you don't, and you have trouble with the labs, then you're just creating your own difficulties. She is absolutely fantastic in the help she can provide. And the way things are going, and I regret to say this, but I'm just simply going to put it out there because I'm angry about it in one of the most hostile ways I could be. Because that lab has not been used extensively enough, it's likely that we will replace that lab with something smaller because not enough people are going out there, and some people are angry about that because it's just not being visited enough. So, you have one perhaps of the last opportunities to go out there and get the help. It will, Clarendon will still be involved, but we'll probably be in some lab more characteristically crowded, dysfunctional. We worked for years to get what we have out there. Visit it while you can. It is absolutely a marvelous setting, and I've done everything I can do to try to preserve it. And like Don Quixote, tilting at windmills at this point, am not being listened to. So, with that said, get out there while you can. Visit it, get the help. It is a superb setting and enormous help available to you. Okay, let's make this all happen now with stat graphics. Enough of the soapbox. I'm going to go ahead and bring the laptop up. I'm going to minimize where I was. And just to point out, if you haven't been doing this in the lab, let's go to the document cam. Here's the icon for Centurion. That is a download for 30 days. We have a serial number or an access code that we can do for that, so you can use it the entire semester. I've explained to you before, I don't think it's worth what you get. So we're going to go to StatGraphics 5.1 because you can continue to use it, and it does a great job for what we want. So there's your page that comes up. It's that fast. I'm going to go to here, bring up the upper left corner, and I'm going to open the data file. That's the third icon if you haven't figured that out at this point. Double-click on that. And what I'm going to do is bring up then the World Factbook 2008. I'll comment here before I click on this. One of the things that's still getting emails on, and you understand that I have about 60 to 70 students who are sending me emails each week from the 2 video-based classes. And the question, I double-click on the file when it's on the desktop and nothing works. Bottom line, open up StatGraphics, then open up your data file with StatGraphics. Otherwise, you have to create the association in Windows so that when you double-click in the file, it will come up with StatGraphics. So again, as we come back to the computer, I have this now opening. I'm going to do the traditional double-click there to save time. And here is my database. Now, as we go up to describe, I'm doing chapters 1 and 2. They are descriptive. We have both numeric and categorical data. I want numeric data this time rather than the categorical data that I did in the last lab. I want one variable. I could do more variables, but for the moment I'm focused on birth rates. So I get the pop-up. And when I do that, at the top of this, I have birth as my second item. I will double-click on that and then either do an enter or an OK. And when I do that, we get this as a default. Now I'm going to come down here in the bottom left-hand corner. I'm going to double-click on that with the left button. And when I do, I get these summary statistics. Now, I can change what I have on here. I could right-click, and I can mix and match. For the moment, I want to point out that what we are seeing on the minimum, the maximum, and the range is precisely what we picked up looking at the database. Okay? So, again, more information here than we want. Let me just mention 2 things here that are typically part of it. Skewness and kurtosis. Now, kurtosis is how leaping into the air your curve is, or how plateau-looking it is. So leaping in the air like a ballet performer, lepto, and plateau, Plato. So we look at something that is peaked very high as leptokurtic, and the very flat, platokurtic. And so to that extent, we measure those with numbers. So as I look at this, I haven't tried to explain to you the standardized skewness or kurtosis, but that is something that a little bit later I'd like to come back to. The quartiles you can see, and the interquartile range, so you know immediately you could do what with that information?
5-number summary?
5-number summary, yes, and you could get yourself a box plot. Right? And you can get the fences very quickly. Now the question, how do I mix and match here? Because I have a statement as to what I want you to have on this particular page. I'm going to do a right-click and then go to Pane Options. And when I do that, I see this mix and match setup. So let me bring that across here. I have average. Remember, the average means the mean. Bad choice of words. The average is interpreted as the mean. Then you have the median. The mode, remember, is the data value that occurs most often. The variance we've talked about. This geometric mean that I have here is not the mean we are using. That is taking the product of values and then taking the nth root if you had m values. The standard deviation we have. The standard error is related to those x bars we had in the first couple days. And I ask you to get the mean of the x bars. If you get the standard deviation of the x bars, it's called standard error. Then, of course, we have the minimum, the maximum, the range, Q1, Q3, IQR. And over here on the right side, we have skewness and kurtosis without standardizing them. Then we have a coefficient of variability and the sum, which is your sigma x. So I do have a request in the lab as to what you should select. Deselect anything else just by clicking on it. So with that said, I'm not interested particularly in that panel further. The only thing I get as a freebie here is the box plot. Now, I'm going to look at that to the extent that there's certain things I want you to be aware of. I'm going to go to graphics options for just a moment, and what I'm going to do is do the colors so that we get something that is at least more readable. There. Now, what I want you to note as I zero in on this, there's my mean marker in red. Now, just as a comment here, because it's something that's worth noting, I'm going to click on that marker. It turned white. I'm going to right-click, and I'm going to go again to Graphics Options. So that's what I've done up here. And I'd like that to be a little more visibility. So what I'm going to do is come down here and increase the point size. So I'm simply going to make that a little bit larger. And then in the point thickness, I'm going to make a little bit larger. I'm running those both to about the midpoint. Okay, and I'm going to say, as I look at that, I've got to see what I have there. I want to apply that. And then I'm going to do OK. So I went down to Apply, and then an OK. And now, let's see what we get. Now, even with full screen, you see the mean marker, correct? Remember this operation, because if I see your mean marker on box plots, and I have trouble seeing it, and it wouldn't go well on a PowerPoint presentation or a slide, then I will be taking a half point off. So that mean marker is very important. Let's come back and look at it again. What is it telling me? One more time. Anybody? Skewing to the right because the mean is to the right of the median. Okay, back to the diagram one more time, Jennifer. What else suggests skewing to the right? The longer whisker on the right, correct? Notice the absence of little boxes and little boxes with stars in them. What does that tell you? No suspicious or extreme points. Okay. I'm going to double-click on this just to minimize it, and I'm going to come back up here just again to pick up some additional information. So as I look at the analysis toolbar, now this is where I'm actually going to go with graphics options, but I want to look at this for a moment, the tabular options. Now what I'm doing here is getting something that's not related to the lab directly, but notice I have a stem and leaf display as an option. I want to look at that. Now, as we come off there, why would I want to look at this? What is my argument about histograms versus stem plots that I just said 10 minutes ago?
Because you can't manipulate a stem plot as well as you can manipulate a histogram.
Precisely stated, Sean. Stated, I cannot manipulate a stem plot as easily as I can a histogram. So let's see what the stem plot gives us, and what we would like to then reflect through the histogram. And you might say, well, why not just do stem plots? Folks, not everybody knows about stem plots, and I find that a deplorable situation. They've been in the textbooks now since about 1990. They were first stated in 81 through the book by John Tukey on exploratory data analysis. But you've got professors who've been teaching long as I have, and they did not have it as part of their work. And if they have not been doing an introductory course, they may not use stem plots. And you're wanting to represent something in a senior research project, a master's thesis, a doctoral dissertation, and you go to stem plots, it's not as acceptable as a histogram. And the same for the public who are reading research reports and summaries. So histograms have a lot going for them. At any rate, I've clicked on the stem plot as we go back. I'm just now going to click on the OK, and let's see what we get out of this. Now, the lower left-hand corner is my stem plot, stem and leaf display. Okay, this is the mess I have. Now, do you see why? The skewing on the right side. Now, I need to scroll this a little bit more because I've run out of space. There's my full graph. So here is my skewing on the right side to the extent where I've got the cursor going back and forth or up and down. I hope that is visible to you. That is more or less the center of a bell-shaped curve that would be less the lower tail. So we see the right tail. So one would argue a skewed distribution on the right side. Down here, okay, this is about, let's see, I have it as about 3 intervals from the bottom. Again, I'm going to move this cursor up and down like a bouncing ball. What does that suggest down here?
Bimodal.
Another distribution that's bell-shaped with this 1, 2, 3, 4 intervals. So this is your underdeveloped country population. This is your industrialized group up here. We have 2 groups in the same graph, 2 populations, hence bimodal. But nonetheless, that's what we have when we look at birth rates. Now, I've mentioned to you that the critical issue in taking X bar and S as a descriptive analysis is that you have the bell-shaped curve. I don't. But I'm more interested in taking a sample from this distribution, a sample of 30 or more countries, and looking at the distribution of means. That's what we did the first week. We did 18 of them. Here, we are interested in the shape of the distribution of the means. That's called the sampling distribution. And the argument, we're going to represent that in a lab, the argument is that that distribution will be bell-shaped even if you got garbage in the original population of data. So I have a bimodal distribution of birth rates. I am going to take means from that database. And I'm going to look at the distribution of those means, and the argument is if I get all of them, not 20, but all of them, I would have a bell-shaped distribution. That's what we're going to try to replicate in labs. That's the effort. That'll be in the 7th and 10th lab. In the 3rd lab, I'm trying to establish for you that we have this bimodal shaped distribution. That's the goal of this 3rd lab. Will you please reflect for a moment? Question 5, discussion questions. Part A, what is that question? 5A in the lab, and it stays that way through every lab you do. You've done it twice. What are you supposed to respond to?
A summary of the...
No, that's 5C. 5A, not the summary. What is the purpose? Translation, objective, goal, purpose of this lab. So what is the purpose of this lab? To determine the shape of the distribution of the population of birth rates in the world. Why? Because we would like to demonstrate that it's not bell-shaped with the intent of demonstrating the central limit theorem in a future lab called lab number 7. How's that for writing your answer out for you? Now, if you need that rerun, channel 96, 5 p.m. Or if you don't have Comcast, because you've been doing DirecTV or some other effort, then the library at the reserve desk. At about 11, 12 o'clock in the afternoon, 11 o'clock in the morning, there will be a VHS tape over there, and you can watch that. Or you can reference your notes. Enough said. Now, back to my computer. I'm going to double-click on this to minimize it. That brings me to a box plot I didn't want. I want to minimize that. I need to bounce back and forth like a rubber ball, it seems. So let me go back up here. What I want is the analysis I did. So I'm coming up to the window, and I'll drop down here. And I wanted, pardon me, the one variable analysis. It's down there at the bottom. That's what I have up. I should be okay. So let's see why, when I double-clicked, I didn't get what I wanted. So I'm going to come off there. I'm going to double-click here. Okay, that's interesting. My computer is ignoring me at the moment. Okay, let's see what I can do here. Okay, I'm going to try deleting that analysis and come back up to the top. I have no idea why it decided to be obstinate. Nonetheless, it was. So let me just carry through this very briefly. I'm down to where I was before with the full analysis. And what I'm now going to do, and by the way, I have a hunch as to what's wrong. And if you run into this problem, I've been using this for a couple weeks now, bringing up web pages and so on. And my guess is I need to go into IE, Internet Explorer, go into the place where you can delete temporary internet files, because IE, Internet Explorer, uses the same portion of your hard drive that StatGraphics is using. And so if you have overused that partition of the hard drive, then StatGraphics doesn't have anywhere to go with what it's doing. And so I probably should clean that out. Now's not the time to do so. Okay, I'm up here again on the third icon. Okay, let's see if I can get it to at least, there we go, graphics options. So this time I'm interested in the graphics options, and I want the frequency histogram. I've placed you there before. So we'll click on that and do an OK, and this is the default I get. Now, what do we see in the default? Is it pretty darn close to what we saw in the stem plot? Yes or no? Just say yes or no. Yes, I'm hearing in greater frequency than any no's. I'm going to ask you to look one more time if I can get this thing now to cooperate. Let's see if I can do an overscan. No. Let me see if I can drop down. That's not going to work. Okay, what I'm going to try to do is control this output. There we go. Let's look now. Do you note what I was telling you about relative to the default? Where is it running from on the horizontal axis? 0 to 60, correct? And so that is, to some extent, manipulating this histogram in a way that I'm not real pleased about, given what I want to do. So that's what we're going to address. Now, how many intervals does it look like it defaulted to? 7 bars, agreed? 7 bars. Well, what I'm going to do is, just for a moment, and you can follow what I've done, I've selected the histogram. You can see the little red marker coming up. I'm right-clicking, and what I'm going to do, I'm sorry I cannot handle the Pink Panther this morning. So I'm going to Graphic Options, I'm going to do Fill, I'm going to go to Colors, and what I'm going to do is select what seems to work pretty well for this screen. I'm going to the yellow and do an OK after I applied it. I'm much more content with that. It looks like sunshine in the morning rather than the Pink Panther and Peter Sellers. That ages me if you don't know who Peter Sellers is. Now, I'm going to go ahead and right-click one more time. When I do this, I'm going to, this time, come up to Pane Options, not Graphics Options. And when I do that, I find something very interesting. As I look at what the default was, and I'm going to just deselect, it went for 9 intervals, correct? But you only saw 7. Why? Give me your argument for why you only saw 7.
Because there's nothing in the other 2 intervals?
You went 0 to 60. So probably it was between 0 and 7 on the low end, nothing there. And on the upper end, it ended up with 60. So you probably were going 50-something to 60, and there's nothing there. So it looks like we had 7. It really went for 9, but we want 8. So let's come back to this. Now I mentioned to you the default. There's my lower limit and upper limit. And if you want to understand boundaries and limits, again, it's in the student study guide that explains that. There's my 8 I want. Now, we've already done our homework here. We know that we're going to go to 7.365, correct? And we defended that on the board. Let's come back to the board for that for a moment, Jennifer. That's still up there. That was the 7.365. And then our upper boundary is what? 49.765. So let's come back to the screen. So here I want 49.765, if my memory was adequate. This is an important key right here. Hold. Hold them. Don't fold them, hold them. The idea is that if I want to now change the title, if I don't hold what I've done here, it will revert back to where it was before I made the changes. This always surprises students. One of the things that you have a very implicit responsibility to do is check what you take out of the printer. That may sound oversimplified, but I've had students who simply take it out of the printer, attach it to their lab, and never look to see what's on there. Remember WYSIWYG? What you see is what you get. Stat Graphics is not WYSIWYG. You have to make sure that you're getting what you think. How do you check that? First, go to Print Preview to save ink and paper. I used to say just ink. We're out of paper in the other lab. I'm still trying to get paper out to Clarinda. We have a paper shortage because we didn't have a budget when we should have ordered. Now we have the budget, but now it takes time to get the paper. So paper and ink. I mean, we're getting to the point where maybe we send you to Walmart, buy an ink cartridge, buy paper, and then you contribute that to the school because the state budget isn't, as you know. Maybe by Christmas. That's a sarcastic comment. Arnold, take notice. Now, as we go with this, I'm going to say OK here, and I should see a difference. Now, I'm going to zoom out, so when I say OK, we should now have 8 intervals instead of what? 1, 2, 3, 4, 5, 6. I'm at 7. Did I not apply? And that may be something I should have done. I did not. Okay, I'm okay there. 7, 3, 6, 5, 4, 9, 7, 6, 5. I've got the histogram. I've got 8 intervals. That should have undergone a change. What is this suggesting? Remember I was hung up earlier? Didn't get what I wanted? The program is not responding for me. Let's see if it did this time. 2, 4, it finally did. So when things aren't working, try again. Okay, now do I have 8? 1, 2, 3, 4, 5, 6, 7, 8. I've got some real problems with memory in my computer at the moment. But it worked. That makes me feel better. Don't like being ignored by the computer. There's a neat cartoon with Bumstead this morning, Blondie, Dagwood and Blondie, where he's trying to exit his computer. And it says, are you sure you want to exit your computer? And then asks it a second time, and then it says, well, if you'll say, pretty please, and he's still trying to exit the computer, you haven't had that happen to you. You just haven't been spending enough time with Windows when it wants to do its upgrade, and it doesn't when it turns off, and it takes 15 minutes to close down. Okay, naivete. Well, going back to the computer. This time, what I'm going to do is come to the bottom of that, and I'm going to move over to the side. I want you to see what happens as I click on the numbers here. Well, I can see it on my screen, and I don't know, can you see the yellow there? That indicates you selected it. So you left-click to select, right-click, and then come up to what is going to be graphics options. And that should put me to something that allows me to change the horizontal axis. And it did. The from down here right now is from 0, right? But I want it from what? Back to the board for that data, if you would please, Jennifer. I want the 7.365. This must be identical to what you did to set up your original histogram. Back to the board, the 2 part. Not 50, but 49.765. Now, this is not intuitive. The by part sounds like we are in business, but it's a BY, not a BUY. This is your width, and what was our width as we go to the board? 5.3. Now, I've carried through this as explicitly as I could possibly do it. We're not skipping anything. Down here, I want to hold that because I'm going to change the title, and I don't want to lose things. But note this. Rotate the axis labels. So if, as I come off there for a moment, if I find crowding, too many digits overlapping each other in the horizontal axis, I can rotate them to vertical and avoid the crowding. It's an option. I'm going to try it the way it is and hope that things work. And given an opportunity to apply this rather than an okay, I'm applying, then do an okay. And note what I've got. A very crowded situation. Agreed? Now, it may not be so crowded if I do what? Print preview. WYSIWYG. So let's see how bad it is. So I right-click, print preview, and I look at the bottom. Bring it. Not so bad, but what? More crowded than you might like. Agreed? So I'm going to close that. I'm going to come back down here to the bottom of this. Left click again, right click, go back to graphic options. And now I have my numbers. Everything's as it was. That's why I held it. Now what am I going to do? Rotate. Do an apply. Do an okay. And is life better? You're darn right it is. And notice everything matches up exactly where I want it, but this bugs me. So what am I going to check? Print preview. I'm going to get you programmed yet. So we're going to go print preview, come back up. Now, as long as you don't forget anything here, you're in business. But if you forget something, that's why you may want Clorinda's help. So let's see if this is what I wanted. Oh, that looks pretty good, right? Now, question for you as I zoom out on this for a moment. And let's see what I'm going to do. Just a moment. I need to, okay, zoom out, not zoom in. Okay. That was not good. There we go. Comment, good or bad? Let's bring that back up for a moment, Jennifer. Good or bad? What am I trying to emphasize? What's the goal? To emphasize what? I heard somebody mouth it, but I didn't hear it verbally.
The bimodal distribution?
The bimodality. Does this show it?
Yes.
Pretty darn well. Do you think it would show it as well if I went horizontal? What happens as I go to landscape mode as we come off there? It widens it at the expense of what? Compressing that vertical spread that we want to emphasize. So the key would be go portrait rather than landscape to emphasize what you want the reader to see, which is the non-normality of the distribution of birth rates worldwide. Am I done with that graph yet? No. What else do I have to do? Title it. Agreed? Okay, back to the computer. I'm going to close this because I want to get back to my graph. And there is I got in between. There's my title. So I'm going to left click, right? What should I see show up if I left click? Both sides. I call them handlebars. I should see little yellow, and I see just barely yellow. If I had gone passionate green or purple, you'd see it better. I can't handle that. So right click, graphics options, even though I did purple haze. That's in the contradiction, I guess. Okay, so there's the title. You know what you have to do there. I'm not going to say too much about that. You have to add parts to it. But what's going to happen if you add it and you try to get your name on there? What's typically going to happen? You're going to run out of space if you have a long name. So if you title this and you run out of space, then what do you do to get a new line for your title?
The little ABC button.
The ABC icon, which is not related to restaurants and liquor. Okay, never mind. Go ahead. You people are asleep this morning. Okay, histogram of birth rates. World Fact Book. I don't know what I've asked you to do, but I'm just opting something here. And I'm going to put in by, and I'll do what I usually demonstrate here, and do an OK. Oh, and it ignored me. Right-click, graphics options. I did not hit the apply at the bottom. Okay, so live and learn. Histogram of birth rates, abbreviated to save space and time, and I will apply it this time, and maybe the computer will cooperate with me. So I will apply. Yes, it did. There. Okay, now, as I bring this zooming out, that filled up the space rather well. A comment here, I haven't talked about this other than critique some of your printouts. If you're running a size 8 font and you're trying to create a table and you want somebody to see it as a presentation, it won't work. Increase your font size on titles so it's something that's readable. I told you at the beginning, I'm going to make an editorial comment here about your labs. I just did some work before we started about stem plots and such. I did that relative to the pie chart and bar chart on the first day of class. And then on what you produced for me, you ignored a lot of what we did that first day. Said you don't want stat advisors. I indicated you wanted to use full page, that is 100% vertical and horizontal scaling. And you took notes. But you got to read the silly things when you reference what we're doing in a lab. So if we're doing something with stack graphics, have a portion of your notes maybe where it's just reserved for stack graphics and then reference it. Otherwise you lose points. Now for those of you who are watching this at home and you're doing the video-based course, for crying out loud, look at the week at a glance. The week at a glance tells you precisely what you're supposed to do with the fifth question, what you're supposed to do with graphic scaling, and about 80% of the labs turned in by the video-based group are losing points because people did not read the week at a glance that's obligatory for each week. For those of you in here, if you want to know what you're responsible for, it's a good place to go and look also, because all the issues are covered on the week at a glance for the video-based class. Now, back to the computer. Pent-up hostility this morning, I probably would be best described. It helps when you get sleep and you don't feel that. Let's go to the ABC icon. If I click on that, I get a new pop-up, and on that new pop-up you can add text. So I'm just going to put some Z's across there for the moment and see where it goes once I do that. So as I did that, I find that the Z's, okay, are up here under the title, and if I wanted space for that, what can I do? Left click there and drag up, left click here and drag up, called click and drag. That's how you do it. Well, that's just one page of your output. That is one page for you're doing your histogram with 8 intervals. Now, I ask you to do it with 3 intervals and with 20, correct? If you will look at the lab directions, I've asked you to use as your boundaries the lowest value and the highest value. Back to the board, Jennifer. We've got the low value, we've got the high value. I believe those are your boundaries, correct? And if you will check the directions, in the lab directions for histograms, I believe that's precisely what it tells you to do. Use your highest and lowest boundary as the highest and lowest data point for 3 intervals and 20 intervals. Have we got it? We've got it. So with that said, I'm going to, what do I want to do here? I'm going to get rid of this histogram. So let's come back. I don't want to try to impose everything. Back to the computer, if you would, please.
So you're just using 8 as an example?
Okay, the question. Am I just using 8 as an example? No, ma'am. I just did precisely what you're going to do in the lab directions for when you use 8 intervals. Everything I did you will replicate down to the exact numbers. This was not an illustration of what you're going to try to do. This is what you will do. Now, you do have an option. You don't have to use yellow. But if you use grayscale, no. You choose a color and make sure it's one that your feeling impacts the reader when they see it on a PowerPoint, or impacts the reader when they see it on a slide. Presentation. That's what you're interested in. Knock them off their seats with a very well done, well presented, good choice of colors, and you look at it and say, wow. And if instead you say, yeah, then you didn't meet your goal. Is that clear? Presentation graphics. What is a 10? When you knock them off their seats. Now, back to what I have here. I'm going to exit this particular analysis. Oh, that was not good. I not only got rid of the histogram, I got rid of everything. So it'll only take me a moment to get back to where I wanted, numeric data. One variable analysis, I'm double-clicking on birth, I'm doing an OK, I'm coming to the third icon, I'm doing the frequency histogram, I'm there, I'm done, and I still don't like the color I got, so I'm going to bring this up. I think this is taking all of 20, maybe 30 seconds. Left-click, right-click, graphics options, color, fill, colors, yellow, OK, apply, and now I'm where I want to be. So with that done, what I'm going to do is left-click, right-click, and I'm going to come to Pane Options. So I go to Pane Options, and now my default, again, is 9. I want what instead? 3. And instead of lower limit being 0, I'm going to have what? 737. Nothing adjusted. Upper limit is going to be my value for Niger, which is 4962. Okay, I've done it. That's all I have to do. You see the lost information? Any bimodality there? One population, skewed, 3 intervals. But you are seeing something. You're seeing the skewing. But you've lost information. Okay, now we're going to do what? Overkill. 20. So what am I going to do? Left, right, like marching. Left click, right click. Pane Options. And if you're marching, it probably is an appropriate response. 60-mile hike, 80-pound pack, Pane Option, yes. 20. Okay, everything else is the same. Doing okay. Is that noisy enough for you? Broken tooth comb syndrome. Do you see some bimodality? Yeah, but you see a whole bunch. It looks like the New York skyline. So, what is your response to having too many intervals? You create noise. Not enough intervals? Lose information. Now, do you want to show bimodality based on what you know about the stem plot? Yes. So is 3 a valid choice? No. Is 20 a valid choice? No. That's Goldilocks and the Three Bears. Porridge too cold, porridge too hot, and in between is just right. And how do you get the just right?
Like a student.
Powers of 2. 8. That's the lab. You have discussion questions? So you're going to have how many pages of output? 3 pages of histograms. Now, question, do I expect you to title the 3 and 20 histograms? And I believe I do not ask for a title there, so you can just present them, but the one that is the finished one, the 8 that you're going to present to an audience, that I want titled appropriately. So you have 3 pages of output, 1 page for your title page, 2 pages of discussion questions. So that looks like about a 6-page lab. Due Thursday. Okay, Jennifer, I've ranted and raved enough this morning. Back to Jimi Hendrix. At least I will not break...